All right, this is a video for geometry on the volume of prisms and cylinders. I'll show you one really easy formula as introduction, and then we'll go through a few different solved examples. So volume of prism and cylinders, hopefully you get that we're not looking at surface area anymore. We're looking at sort of the interior space that is contained by this three-dimensional solid. Okay, so how much space can fit sort of inside that object. Easy formula. Volume is this. Area of the base times the height. The base might be a square, the base might be a circle if it's a cylinder, the base might be a triangle, okay, or a trapezoid or anything else. And this really only applies to a prism, remember, or cylinder, where the bottom face and the top face are congruent and parallel. Okay, so any sort of a three-dimensional solid like that, this formula applies to. Area of the base times the height. So let's do an example. For a rectangular prism, we could actually think of any of the six sides as potential, or six faces as potentially being the base of the thing. But let's think about the way it's oriented right now. This has a base that is 24 by 20 and then a height of 10. So the area of the base, which is a rectangle, is 24 times 20. And then that being multiplied by the height of 10. So I get a total volume of 4,800 cubic centimeters. Okay, and if you turn this rectangular prism vertically on one of its other faces, you would get the same solution as well. Triangular prism is a little bit trickier because we really only have one set of possible faces that could be the base. This triangle needs to be represented as the base, okay? And the 10 is going to be the height. We have a little bit of a tricky piece here because we have an equilateral triangle, but we don't know the height of that triangle itself. So let's draw a quick sketch of what that triangle could look like. We have a side of 8 and a partial base length of 4. This is going to be a 30, 60, 90 triangle, this piece that I'm shading in here. So that means that this height of this triangle is going to be 4√3. So when we think about the area of the base, and let me write all this out, the volume is going to be the area of base times the height. So the area of the base is going to be 1/2 times the base of my triangle, which is 8, that's this base right there, times the height, which is 4√3, and that's all going to be multiplied by the height of the prism, which is 10. Okay, again, understanding that the prism is sort of on its side right now, to visualize solving for the volume, imagine turning it up vertically so the triangular base is on the floor. Okay, so this turns into 160√3 once we do the multiplication, and we could certainly get a decimal approximation for that, and we get 277.13, and this would all be in inches cubed. So either of those would be a valid solution there. For the cylinder, we have a radius of 3, a height of 8. Sometimes it's nice to just do a quick sketch so you can visualize what you're looking at. So radius of 3 and a height of 8. So let's find the area of the base first. That's going to be pi r squared. And then that's going to be multiplied by the height. Okay, so my full volume is going to be pi r squared times the height. Okay, so this is going to be pi times 3 squared times 8, which turns into 72 pi. And again, the decimal approximation would be 226.19, and this would also be in cubic centimeters. So both of those would be a legitimate solution right there. About 226 cubic centimeters. I just had a random thought, and it's how can we think if that's a reasonable solution? And just as a little bit of a tangent here, let's sort of imagine that this is a rectangular prism with square bases. And those bases you could see could be represented as 6 by 6. If the radius of this circle is 3, the diameter is 6, and you could, as a rough estimate, think of this square prism as having side lengths of 6 by 6. Let's find the volume of that guy, and that's 6 times 6 times 8, and that's 288. So that's just a way of saying, okay, our answer is in the ballpark. This square prism should have a greater volume because we're including sort of the corners that aren't included in the cylinder. But it's a way of kind of checking your work. Lastly, today we'll be looking at a composite figure. And again, a composite figure in geometry is a figure where we have multiple simpler shapes kind of melded together, merged together. I hope you can see that this looks like a half of a cylinder right there. Okay, and I hope we can also see that this cylinder has a radius of 12, okay, and that would make this, the missing base of this rectangular prism, be 36. Okay, so we have two pieces being added together. So my big suggestion for this is to keep track of everything, okay, in an organized manner. So my volume is going to be the rectangular prism plus half of a cylinder. Hopefully you can see that's a cylinder chopped in half. So the rectangular prism has an area of the base, which is 36 times 24 times a height of 24, plus a half. The cylinder would have an area of a base, which is pi times 12 squared, and then a volume of times the height to get volume times 24. Okay, so let's multiply all this out and see what we get. So I get 20,736 for the rectangular prism portion of the volume, plus 1728 pi for the half cylinder portion. So that would be a fine exact answer, but this would be approximately equal to 26,164.67 cubic inches would be the volume of this fish tank, the approximate volume of the fish tank. All right, big suggestion is just to keep track, stay organized, and keep track of the different pieces so that you don't forget a piece here or there. All right, nice job. We got through it, and that's a great place to stop.